Good morning, and welcome to Hypothetical Science. And today I would like to talk about galactic rotation curves and dark matter. Right, Ruby? Now, it was in the mid-70s when they started measuring how fast stars were going around the centers of galaxies. And they found that the outer stars were going way faster than what they should be going, according to our theory of gravity. The outer stars were going around as fast as some of the inner stars and the middle stars. I mean, it looked like the whole thing was going all around all together, and that's totally wrong for our gravity theory. The outer stars should be going around very, very slowly. Like, for example, our planet Pluto hasn't even made one orbit in the last, I don't know, ever since it was discovered. So that was in the mid-70s that they found out that galactic rotation curves, or GRC, they found that GRCs were flat, and that's what that means. A flat GRC means that the speed doesn't get slower as you get further out. The rotation stays the same. So right there, I knew that our gravity theory had a problem. But science started scrambling around, and they came up with this old theory about dark matter that had been brought forward by Lemaitre or somebody back in the 20s. Oh yeah, well, maybe there's a halo of dark matter around, and then it's just like pulling the outside stars around faster. Yeah. Except, like, how can you have something outside the galaxy? Oh yeah, it's going to pull those outside stars faster coming towards it. But when the stars go past it, it's going to be pulling it back. So, I don't know. Dark matter never made sense to me in a bit. But they see these stars going too fast, and that's their evidence of dark matter, right? So we've been looking for dark matter ever since because of flat GRCs. Okay, so when they create these GRCs, they find that if they take a galactic rotation curve from one side of center, it's one shape. But when they take it exactly the opposite direction from center, it's a different shape. And they're not symmetric. And that's a big problem. It's called asymmetric GRCs. So to get the GRC for the whole galaxy, you take the average of these two. And that's how they get the GRC for the whole galaxy, is they average it. And then you get the GRC. Now, why are the GRCs different on one side of the galaxy from the other? Well, what the explanation seems to be, or has been, or I've heard, that they believe that the stars on one side of the galaxy are going faster than the stars on the other side of the galaxy. Now, if you think about that for a second, say you got a racetrack of cars, a bunch of cars, half of them are going faster on this side, half of them are going slower on the other side. Well, it's not going to take very long before you get everybody backed up going slower on the slow side, and a lot fewer cars on the fast side. And we don't see that in galaxies. We see symmetry. But the two sides, the two GRC sides are different. So why is that? Why does it appear that the stars on one side are going faster and the stars on the other side are going more slowly? Well, it's because galaxies are precessing. As well as turning, the plane of the galaxy is changing. One side is going away from you, the other side is coming towards you. And it's because of the precession of galaxies, which is double the rotation, that you see these GRCs being asymmetric. And it was GRCs in the first place that started them scrambling to find this fictitious dark matter, which they're still spending a lot of money trying to find. But you know, you try to find stuff that isn't there and you're probably going to find a lot of stuff that is there. So it's not totally wasted money, but crazy. Anyway, this has been hypothetical science. I'm not saying I've got true science. I'm just saying that based on the hypothesis that atoms and galaxies are exactly the same and that the universe is fractal, then this is the answers I'm getting. Right, Ruby?